Topic is spanning tree of graph. Spanning tree of an undirected graph is a subgraph, that is a tree which includes all of the vertices of graph with minimum possible number of edges. What is spanning tree of graph? Spanning tree is a subset of graph which has all the vertices covered with minimum possible number of edges. Let a graph capital G has n vertices and e edges. Then spanning tree of graph contains n vertices and n minus 1 edges. Spanning tree has no cycle which are a tree and it cannot be disconnected. Now consider an example. First figure shows a graph. Vertices are A, B, C and edges are A, B, B, C and AC. Second figure shows spanning trees. Now in this figure, three spanning trees of one complete graph. A complete undirected graph can have maximum n to the power n minus 2 number of spanning trees, where n is the number of nodes. The address is 3 to the power 3 minus 2 equal to 3 spanning trees are possible. Now next, what are the properties of spanning tree? Now first property, a connected graph can have more than one spanning tree. Second property, all possible spanning trees of graph have the same number of edges and vertices. Third property, the spanning tree does not have any cycle, that is loop. Fourth property, removing one edge from the spanning tree will make the graph disconnected, that is the spanning tree is minimally connected. Next property, adding one edge to the spanning tree will create a circuit or loop, that is spanning tree is maximally acyclic. Now, what are the applications of spanning tree? The first application, civil network planning. Second application, computer network and routing protocol. And third application, cluster analysis. Now, these are the applications of spanning tree. Now, next topic is minimum spanning tree. In a weighted graph, a minimum spanning tree is a spanning tree that has minimum weight than all other spanning trees of the same graph. This is called minimum weight spanning tree. So we define minimum spanning tree. Minimum weight spanning tree is a spanning tree where the total edge weight is minimum among all the possible spanning trees of the given graph. Such spanning tree with minimum weight is called minimum weight spanning tree. Minimum spanning tree is not necessarily unique. Now consider the following graph. Find the minimum weight spanning tree of graph. Now see the figure first and see the figure second. There are two popular greedy algorithms for finding the minimum spanning tree. One algorithm is Kruskal algorithm and second is Prim algorithm. Now Kruskal algorithm builds the spanning tree by adding edges one by one into growing spanning tree. This algorithm follows greedy approach, as in each iteration it finds an edge which has least weight and add it to the growing spanning tree. Now this is the algorithm of Kruskal algorithm. Now these are the steps. First step, sort the graph edges with respect to their weight. Second step, start adding edges to the MST from edge with the smallest weight until the edge of the largest weight. And next step, only add edges which doesn't from a cycle, edges which connect only disconnected components. Now these are the algorithms of Kruskal algorithm. In this algorithm, at each iteration will select the edge with the lowest weight. So it will start with the lowest weighted edge first. That is the edges with weight 1. After that we'll select the second lowest weighted edge, that is edge with weight 2. These two edges are totally disjoint. Now the next edge will be the third lowest weighted edge, that is edge with weight 3, which connects the two disjoint pieces of the graph. Now they are not allowed to pick the edge with weight 4, that will create a cycle and it can't have any cycle. So it will select the fifth lowest weight edge, that is edge with weight 5. Now the other two edges will create cycle, so we'll ignore them. In the end, it end up with minimum spanning tree with total cost is 11. So this algorithm is used how to find the minimum spanning tree with a total cost. Next algorithm is prime algorithm. Now prime algorithm also use greedy approach to find the minimum spanning tree. In prime algorithm, we grow the spanning tree from a starting position. Unlike an edge in Carlos curve, we add a vertex to the growing spanning tree in primes. Now this is the algorithm. The first step is maintain two disjoint set of vertices, one containing vertices that are in the growing spanning tree and other that are not in the growing spanning tree. Second step, select the cheapest vertex that is connected to the growing spanning tree and is not in the growing spanning tree and add it into the growing spanning tree. This can be done using priority queues. Insert the vertices that are connected to the growing spanning tree into the priority queue. And third step, check for cycle. To do that, mark the node which have been already selected and insert only those nodes in the priority queue that are not marked. Now consider example. Now this is an example. You see the example of prime algorithms. In prime algorithm, it will start with an arbitrary node and mark it. In each iteration, it will mark a new vertex that is adjacent to the one that we have already marked. As a greedy algorithm, prime algorithm will select the cheapest edge and mark the vertex. So it will simply choose the edge with weight 1. In the next iteration, three options edges with weight 2, 3 and 4. So it will select the edge with weight 2 and mark the vertex. Now again three options edge with weight 3, 4 and 5, but it can't choose edge with weight 3 as it is creating a cycle. So it select the edge with weight 4 and we end up with the minimum spanning tree of total cost is 7. Next topic is traversing a graph. Graph traversal is a technique used for searching a vertex in a graph. The graph traversal is also used to decide the order of vertices to be visited in the search process. A graph traversal finds the edges to be used in the search process without creating loops. That means using graph traversal, we visit all vertices of the graph without getting into loop path. There are two graph traversal techniques. They are first depth first search and second breadth first search. Now first is depth first search. Now DFS traversal of a graph produces a spanning tree as a final result. Spanning tree is a graph without any loops. They use stack data structure with minimum size of total number of vertices in the graph to implement DFS traversal of a graph. Use the following steps to implement DFS traversal. Step 1. Define a stack of size total number of vertices in the graph. Second step. Select any vertex as starting point for traversal. Visit that vertex and push it onto the stack. Step 3. Visit any one of the adjacent vertex of the vertex which is at top of the stack which is not visited and push it onto the stack. Step 4. Repeat step 3 until there are no new vertex to be visited from the vertex on top of the stack. Step 5. When there is no new vertex to be visited, then use backtracking and pop one vertex from the stack. Step 6. Repeat step 3, 4 and 5 until stack becomes empty. And step 7. When the stack becomes empty, then produce final spanning tree by removing unused edges from the stack. Now these steps are used in depth first search. Now next is a DFS break. BFS traversal of a graph produces a spanning tree as final result. Spanning tree is a graph without any loops. They use Q data structure with maximum size of total number of vertices in the graph to implement BFS traversal of a graph. Now use the following steps to implement BFS traversal. Step 1. Define a queue of size total number of vertices in the graph. Step 2. Select any vertex as starting point from traversal. Visit that vertex and insert it into the queue. Step 3. Visit all the adjacent vertices of the vertex which is at front of the queue which is not visited and insert them into the queue. Step 4. When there is no new vertex to be visited from the vertex at front of the queue, then delete that vertex from the queue. Step 5. Repeat step 3 and 4 until queue becomes empty. Step 6. When queue becomes empty, then produce final spanning tree by removing unused edges from the graph. Now these steps are used in BFS.